We're going to step on the great unconformity.
Where's my directress? There she is. Anyway, good morning, ladies and gentlemen, and from being on the boat with you for several days, that covers most of you. But Janet has kindly asked me to talk about 6 million years of evolution in 15 minutes. And I'll try to make it brief no matter how long it takes. And I've talked about really two areas of human evolution. I am what is called a paleoanthropologist. That's not somebody who studies old anthropologists, but somebody who studies human evolution. And I am based at Arizona State University and run an institute which is called the Institute of Human Origins. And our purview is what I like to call the human career. And the human career for me spans the time roughly between, actually it spans the time from when there was a separation from a common ancestor. One of the major tenets of Darwin's Origin of Species was that there was a common ancestor to the contemporary African apes, chimpanzees and gorillas, and humans. And he proposed that in the late 1800s in a book called The Descent of Man in 1871, which was elaborated upon by Thomas Henry Huxley, who wrote a book, Man's Place in Nature. Not politically correct today. You know, there used to be great titles in anthropology, like The Sexual Life of the Savages by Bronislaw Malinow. We're not allowed to publish those things anymore. And at any rate, he wrote a book called Man's Place in Nature. And in there, he notices the extraordinary similarities in the skeletons and the teeth, and ultimately the soft anatomy of humans and the African apes. And based on those similarities, the way the body is built, essentially, he suggested, as did Darwin, that the earliest ancestor that would be found for humans would be in Africa, because that's where our closest relatives live today, the chimps and gorillas. And they must have had a common ancestor. And we think that common ancestor was somewhere between, I think, 6 and 10 million years ago. That's about as close as we can say right now. So as a young scholar, I read books about these ideas. When I was about 12, 13 years old, I read Man's Place in Nature, which was the turning point, probably, that epiphany, that moment of clarity in my life when I decided that I, too, wanted to go out and find fossils. And at about the same time, a few years later, in July 1959, Lewis and Mary Leakey announced the discovery of Zinjanthropus, or Nutcracker Man, from a place that I think some of you have even visited, Olduvai Gorge. And this was about 1.8 million years. My neighbor, Paul Laser, who introduced me to anthropology, came over with the New York Times and said, look at this. And that's when I really made the decision to become an anthropologist. I did my undergraduate at the University of Illinois and my PhD at the University of Chicago in 1974. The same year, I was fortunate enough to make the discovery of the Lucy skeleton. So I was particularly interested in the very early stages of human evolution, Australopithecus, as it's called, or ape man, predominantly known from South Africa, but also known now from East Africa. And I will simplify a little and say that there are two major groups of hominids. Hominids are creatures that walk upright. That's the single defining feature. I asked Dave that question yesterday and said, what do you all do that no other animals do? And nobody answered. And that's walking upright. That was one of the keys for Darwin, because he saw that all mammals and all primates are quadrupedal. It's one of our unique features. Everybody says big brains, culture, language, tools, and so on. But the primary thing, the defining feature of what it means to be a hominid versus an ape is locomotion. So locomotion seems to be pretty darn important. And we could talk about why, because if there are 6 billion of us today, and we're in the ascendancy, and apes are in the decline since the Miocene, there must be something reproductively adaptive about it. But we'll talk about that later. So I was interested in the very early stages, the ape-like stages of human evolution. Had a chance in 1970 to travel to Africa, to Ethiopia, where I worked in southern Ethiopia, just north of Lake Turkana. with Professor Howell at the University of Chicago. And after the first expedition, it was set in stone that this was going to be my life's work. In the early 70s, I met a Frenchman named Maurice Taïeb. I'm going to Paris a week from yesterday to participate in a conference in Aix-en-Provence, which is the 32nd anniversary of the discovery of Lucy, with Maurice Taïeb, the geologist who actually found the site. And he invited me to go with him in 1972, and we found vast fields of highly fossiliferous, fossil-rich geological strata that were essentially like the early sediments we saw here when we first came into the canyon, sedimentary. So they were laid down in rivers and lakes and deltas and so on, and the bones were gradually turned into stone. And in 1974, I found, actually my first discovery was 1973, which launched a couple of decades of intense argument about that essential feature of what it means to be human. It was a knee joint. It was the top end, the shin bone, and the bottom end to the thigh bone. And the way they articulate, the way they fit together, as a trained anatomist or anthropologist, you look at it and you immediately know if it's a quadruped or a biped. And I knew it was a biped. The oldest evidence at that time for upright walking was probably around 2, maybe 2.5 million. This knee joint was 3.4 million. So it was a giant leap back. And it led to a whole series of discussions of why bipedalism. And one of the things that Dave and I have been talking about a lot as scientists is very often what impedes science more than anything else is asking the wrong question. And since Darwin and even Aristotle noted that upright walking was a distinctive feature of being human, everyone has asked that simple question, why did we become upright? And nobody came up with an answer. Some people said it was to reach for fruit. Well, why leave the trees? Some said it was to make yourself bigger for display. Well, you can stand up and get back on all fours and run. Some said it was to look over tall grass when you left the forest and entered the savanna grasslands. Great, here you are, puny little 3-foot tall hominid, leaving the security of forests where you and your ancestors have evolved for millions of years. You go out in the savannah with saber-toothed cats, leopards, lions, stand up to look over the tall grass and announce to every one of them you're on the menu, out of the gene pool. We wouldn't be here. And the reason that all of those explanations failed was because that was the wrong question. And the question that I began to ask after this discovery, it was not my specialty was chimpanzee teeth. And any of you who would like to have a copy of my 444-page PhD dissertation on chimpanzee teeth, we'll be glad to make you a copy. And the question I began to ask was a biological question, and a question that I think that anybody in biology would have asked about a particular adaptation. And our adaptation is bipedalism. And the adaptation is, what were the advantages to the animal for walking upright? Why did walking upright take over as our primary adaptation? And as I said, it has something to do with reproduction, which we can talk about a little bit later. It frees our hands from locomotion. We can use them to, pick up rocks and make stone tools, get a sharp edge like that. That would be a simple, very simple Oldowan initial stone tool. This is not very fine-grained rock, but if we use some very fine-grained rock with a lot of silica in it here, and we did something like that, we would develop an edge here that you could actually use to cut your dinner food. Okay? And that's probably essentially how it began. We look at our closest relatives, chimps and gorillas, but chimps in West Africa will use a favorite rock to gain access to nuts that they can't break. And they have a little hammer and anvil, and they keep doing it. And I can just imagine some little Australopithecus sitting there and doing that, going, oh, cut my hand. And realizing that there was a sharp, it's almost like that beginning moment in 2001, when you see this moment of epiphany, when all of a sudden one takes a femur and starts in that carcass, and those ribs go flying into the air and morph into a spaceship, which is a phenomenally interesting moment, because that's essentially what happened at that moment of the first flake that came off of the stone. It opened up a whole new adaptive niche for us. Because we were upright now and bipedal and could use our hands that were freed from locomotion to make and use tools, we moved in a totally different evolutionary direction, which was called culture. Everything we've done on this trip has been filtered through the lens of culture. If you had to be out here without any tools or whatever, how would you make a living? And that leads to the second major group. As I said jokingly this morning, we're all homos, Homo sapiens. And that happened somewhere, the separation happened somewhere around 3 million years. You had these ape-like creatures, like Lucy, who was the little 3.5 foot tall, 3.2 million year old skeleton of a female, a mature adult, because her wisdom teeth are erupted. Full adult, she was only about that high. Males were about that tall. Lots of sexual dimorphism in size. If you look at apes today, particularly gorillas and orangs, males are much larger than females because they do different sorts of things, but we won't get into that. So they probably had a different sort of social behavior than we have. And perhaps the other significant event, of course, Lucy, I've talked a little bit about her. That was the defining characteristic or event in my life. I was at the University of Chicago, going through my oral PhD exams. That's the time you learn that it's probably, preferable to go to the dentist or your proctologist. It's a lot more fun than having your PhD exam with 4 of your examiners sitting in front of you. As soon as they find out you know the answer to the question, they say, okay, let's go on to the next one. And after the grilling of this about chimpanzee teeth and finally getting the union card, which was a PhD, launched from the University of Chicago, the particularly prickly guy on my committee said to me, he says, well, what are you going to do now, Don? And I said, I'm going to Africa to find something. And I found Lucy that fall. And I wrote him a little postcard, and I said, found something. And it's great to get revenge once in a while on your professors. And Lucy was named after Lucy in the Sky with Diamonds. I had a girlfriend on the expedition named Pamela, and she said, well, why don't you, if you think it's a female, why don't you name it Lucy? Because we were listening to Beatles tapes. And being a scientist, of course, I thought Australopithecus afarensis was much more preferable. But it caught on. And she's become an icon for human evolutionary studies. Whenever you pick up a newspaper or a magazine, a new skull has been found in Ethiopia that's even older than Lucy, or younger than Lucy, or more complete than Lucy's skull. So she's the touchstone by which people judge discoveries in human evolution. You're sitting at a dinner table in New York City, and someone's discussing what John Noble Wilford has just written in the New York Times about a new skull from Chad. And someone says, I don't know anything about this. And then Rich says, well, it's even older than Lucy. And it's like bringing up the name of an old relative, which she is in a funny sort of way. And so that really launched my career. It was the first major discovery in the Afar region of Ethiopia, an area up by the Red Sea, which is about 500 meters above sea level. And there are now numerous expeditions working there and lots of interesting finds.
How did you end up sort of exploring that area? I know you said your friend.
I met this French geologist.
What gave him the idea that was a good area to...
He had seen bones there.
Yeah.
And he said, come and tell me what these are. I don't know what they are.
Okay.
And there were fairly complete skeletons of antelopes and rhinos and gazelles and monkeys. Because unlike the river, where an animal falls in and decays and gets broken up and distributed, this was predominantly a lake, a low-energy environment. So carcass would float out there and rot, and the bones would fall to the bottom, cover them with sand and silt, and slowly, through the process of mineralization, turn into a fossil. So I had great hope, but nothing had been found up there. And I knew it was older than 3 million years because I knew from the shape of the pig teeth I was finding that they were very, very ancient. So this opened up a pretty exciting new chapter in human evolutionary studies. I won't get into the details, but they underwent sort of an adaptive radiation. In biology, that means that there were many different species. We think of ourselves as so unique today as Homo sapiens. We're the only species of human on the planet. As recently as 50,000 years ago, There were Neanderthals, Homo sapiens, Homo erectus, and another funny species called Homo floresiensis. So there were 4 kinds of humans living 50,000 years ago. If we were wandering around Europe, Ice Age Europe, Homo sapiens, we would have run into Neanderthals, which we'll talk about in a second.
What was the difference between those 4 types of human beings?
Well, it's primarily anatomical, shapes of skulls, cranial capacities, anatomy of the face, and culture. They all had very distinctly different cultures. So we had the common ancestor somewhere between, say, 6 and 10 million years, and the separation into the contemporary African apes and into hominids. Lucy's species, afarensis, named after the Afar region where Tesfaye grew up. And Tess's dad was on that expedition that year that I discovered Lucy. I think all of you know that Tesfaye grew up probably about an hour's drive from where Lucy was found. And what year did your dad die? 95? He took his place on the expedition, and we were trying to figure out how to get him to the Grand Canyon. And we did that. He's here now, thanks to his father, who loved him very much and who wanted him to have a great opportunity that he certainly wouldn't have had where he grew up, and willed him to me when he passed away. He was a head excavator for my team. And we're building in Tesfaye's village, by the way, a museum, a National Geographic one. And we will have a safari to the Lucy site, probably not next spring, but a year after. And there'll be this wonderful National Geographic museum, and then we'll go out and camp out, you'll be happy to hear, right at the place where Lucy was found, and we'll know the exact spot. And Lucy's species was quite interesting. We as sapiens think that, and contemporary, modern, behaviorally and anatomically modern humans, think we're so unique because we've been around for, say, 100,000 years. Lucy's species was around for 10 times that length, for 1 million years, virtually unchanged. You know, and futurists are wondering how we're going to make it through the next century. You know? Think about it. When you put yourself in the perspective of time, you get a very different perspective about yourself. And think of the fact that we've been here for a relatively short time. At any rate, so it was an enduring species. We have found it in Kenya, we found it in Tanzania, and we found it in Ethiopia. So it was geographically widespread and ranges in age between 3 and 4 million years. And we're publishing a paper next month in the Journal of Human Evolution, which suggests that she and a previous Australopithecus species form a continuum, as Darwin had talked about, a lineage, from about 4.2 million years right up to 3 million years. We think we've identified one single evolving lineage, which is quite remarkable, something that has never been done before. Then something interesting began to happen around 3 million years. Afarensis disappears from the landscape, and we have, unfortunately, a period of, we have our own unconformities or disconformity. We have a pack of sediments, a package of sediments like this that you see in the Grand Canyon, but you know just above the Vishnu schist and so on, there is an unconformity, a period of non-deposition or erosion, when sediments are either gone or not coming in, okay? And that critical time for me is between 2.5 and 3 million years. And that time period of 500,000 years is missing, almost all over East Africa. There were tectonic movements, there was uplift, there was erosion, and those sediments are probably somewhere, but they're very deep in the Rift Valley, and we don't know where they are. And that's the period of time. The second part of my talk, we talked about Australopithecus. Australopithecus did not make stone tools. Australopithecus was essentially the ape that stood up. It had brains about the size of a grapefruit, had very long arms, inherited from its ape ancestry. It had curved finger and hand bones, but it walked upright. So it was an amalgam of advanced and primitive, or human and ape. So in a way, you could say that Lucy or Afarensis is kind of the missing link in a common sense. because she bridges ape and human. After 3 million years, the climate began to change in eastern Africa, and what we see is it became much more seasonal, became cooler. The vast forests that covered most of Africa at that point now retreated westwards, where the apes retreated with them. That's why you have chimps and gorillas living in tropical rainforest in Central and West Africa. We've never found an ape in any of these early hominid sites, which tells us immediately that they're living in vastly different environmental or ecological settings. And beginning about 3 million years ago, there was a period of drying. Rainfall had lessened, and the forests were beginning to disappear. Probably associated partly with the uplift of things like, if you've been to Uganda or Rwanda, where you have the Virunga Mountains where the gorillas live. That was slowly rising through an orogenic event, a geological event, a mountain building event. And the prevailing winds that were filled with water coming from West Africa hit those mountains and dropped their water. So east of it, where we're looking, was much drier, and the forests began to disappear. And the hominids left the forests. They stayed behind. Probably many species that we have not yet found went extinct. And I believe that bipedalism developed in the forests. I don't think it developed out of the forests. I think a major adaptive shift like that you had to be comfortable with for a very long time. And it's probably related to carrying foodstuffs back to a home base to share with your mate or to make sure that your genes would survive. And how do you make sure that they're your genes? You start pair bonding with one another. You don't want to provision someone else's genes in a typical competitive genetic world. That's part of the explanation for bipedalism. And with the drying, they met new challenges. And there was another split. There was a common ancestor now, which was Afarensis, Lucy species. And there was a split. And a split into two major groups. One group, with this new crisis of living in a whole new area, not being able to live on the fruits that its ancestors had lived on for so long in the forests, sought out a new food source, and that new food source was probably a low-quality vegetarian diet that consisted largely of eating up roots and tubers. They began using digging sticks. We see this polished bone that shows a characteristic polish of digging. They developed very large molars, 4 or 5 times the size of your molars. They had massive skulls with a big crest on the top for anchoring. If you feel the side of your, and move your jaw up and down like that, you feel those muscles moving on the sides. Those are the temporalis muscles. And then you have these muscles, the masseter muscles of mastication. And in these creatures, these descendants of Australopithecus, the jaws became very thick and deep, and large molars, massive muscles to move them. These were dedicated vegetarians. And they ate their way out of this climatic crisis. They made the evolutionary mistake of specializing. They did very well for a long period of time. But when they met the next challenge, they all died out. I use the Gary Larson cartoon in my lectures to explain what being too narrowly adapted means. There are 2 cows sitting in a sofa watching a television program, and the phone rings, and one cow turns to the other and says, "Geez, it's times like this you still wish you had a prehensile thumb, because I can't answer the telephone." So you might be like a horse, really very specialized, and you can outrun a horse, but I tell you, no horse is going to be able to sit and work at an apple, for example, right? Because it's modified its digits down to 1 digit. It does what it does very well, but we know that the only reason we have horses today is because they migrated into the old world. They all died out here where they evolved in North America and were introduced. If they hadn't got across the Bering Land Bridge, Janet would not be out riding horses.
What is the name or names of the descendants of the Afarensis who specialized in vegetarian?
These were a kind of Australopithecus, appropriately called Australopithecus robustus, and Australopithecus boisei, and Australopithecus aethiopicus. Now, these were these massive Cuisinarts of human evolution. And at the same time, there was another branch, and that other branch became a generalist. And in becoming a generalist, it depended mostly on tools for survival. We see the earliest evidence for a simple stone tool at about 2.6 million years. That's when stone tools come into the record. So we have bipedalism. The earliest record we have for that is, I think definitively, would be about 4.2 million, older than Lucy. Then stone tools at about 2.6 million. And immediately after the introduction of stone tools, for instance, if you're going up through the geological sections, as we see in the Grand Canyon, once tools are discovered in the geological record in East Africa, all the animal bones you find are busted up. They show cut marks, they're busted for marrow, bone marrow, and you can see it just by walking the landscape. Where I work in Ethiopia, all the bones are complete. You find complete antelopes and complete monkey bones. But as soon as tools enter the record, they're all busted up and butchered. And marrow, Dave and I were talking about, was probably extraordinarily important for nourishing the hungriest organ in your body. Ed, it's not that organ. It's the brain. It's the brain.
My mistake.
And in order to nourish a brain and keep it going, especially during the period of the first couple of years after birth, which in the first year after birth, the brain grows at the same rapid rate as a brain in utero. So it's not, we don't have 9 months of gestation. We actually have 21 months of gestation. Okay. Did you guys want to go by, or?
Do you mind if we listen?
No, fine. So you can pay after. So bone marrow, which is very nutritious, could have been used to feed young children and nourish this rapidly growing brain. And very soon after the introduction of stone tools and the development of, the acquisition of high energy foodstuffs, we begin to see brain expansion. So by 2 million years, we have brains that are 800 cubic centimeters, twice as big as Lucy's, okay? And then we have another adaptive radiation into a whole bunch of species of the genus Homo, most of which have died out. We tend to think that evolution is a straight linear path. How many of us have seen these, where you see these guys walking like this, and then they gradually get more and more and more upright, right? I love them because they always have as a pinnacle of evolution a white European male, right? You can never tell because they always photograph them in that, but we know they're males. And why are they white European males? Because white European males draw them. And we're very egocentric and chauvinistic about the fact that we think that Europe was a finishing school for human evolution. So there were many species, most of which died out. One lineage did ultimately survive. And it was, I think, who was talking about braided streams today? I think it was Dave. Somebody was talking about rivers and so on. It's, if you look from here back, it looks like a straight line. This is the way I explain it in class. If you take a river in the mountains and you draw it, and it branches into many streamlets or rivulets, if you want to find the source of the river, you go upstream. Every time you come to a fork in a river, you just go upstream. You don't go downstream. So it looks like a straight line. But if you look at it from 3.5 million years ago, and you want to get to a particular spot like this spot right here, you've got all these choices to make because the river's going downstream everywhere. And you never know which branch to take. So it's really perspective, whether you look at evolution from today backwards or from backwards to today. So what happened was there was selection for intelligence. I know it's hard to believe. And because it increased our survivorship, and genes want to do one thing, they want to reproduce. And whatever you do that helps those genes survive is going to have high selective value. And we see the earliest evidence of aspects of behavior that we would consider modern, the beginnings of art, the beginnings of bone tools, the beginning of very sophisticated hunting, at about 100,000 years ago in Africa. And around 50,000 years, to make a big jump, where we started all this at about 6 million years ago, hominids, who we would call ourselves, who were called Cro-Magnon in Europe, because they were found first at the sites of Cro-Magnon in southwestern France, at the site that many of you have been to at Les Aisies, we moved into Europe. And Jean Owl has it all wrong. And Jean and I get into this argument all the time, that we did not move in as light-skinned people. We moved in test-spice color. So the first Europeans were dark-skinned. And we brought with us a very sophisticated technology. And I'll tell you why that technology was sophisticated, and I'll tell you why, as the second, or the end point of the human career, where we've asked the wrong question. The question that we've always asked is, why did Neanderthals die out? The real question to ask is, why did Homo sapiens survive? When you ask that question, because Neanderthals had been in Europe for 200,000 years, they had been selected to live in that environment. They had very short calves, they had very short forearms, they had huge nasal apertures to warm that cold air and moisten it when it came in. They had big sinuses here and here to protect the brain and keep it warm. They had some of the largest brains ever because they needed huge vascular supply to keep the brain warm and working. And they had a whole bunch of other adaptations. They lived specifically on woolly rhinos and mammoths. And they made the same mistake that the robust Australopithecus made. They specialized. They were very good at what they did, but that's all they could do. So we came into Europe after growing up in an environment, evolving in an environment, an African environment where food is distributed patchily over the landscape, seasonally, took a great deal of planning to know where things were that you could eat at certain times of the year, and developed a sophisticated hunting technology that employed long-distance killing, bringing down game at long distances with spears. And when we look at the archaeological record in Europe, we see that Neanderthals brought down mammoths and woolly rhinos, but they did it at close range. They had spears, mounted spears, but they were thrusting types. They had to get right up next to that mammoth or woolly rhino and jab it. And we see that reflected in a very high frequency of broken and healed fractures in the skeletons. So we know it was close encounter hunting. And furthermore, we know that the percentage, the frequency of bone breakage is no different in males or females. So they were so stressed at that point that men and women had to do the hunting. In Africa, a division of labor had developed. Women became gatherers. And what was important about that was that they didn't have to wander too far, and they could care for their offspring and their infants, okay, and not subject them to the dangers of hunting. Males were hunters who went out and did a lot of in-depth planning, knew a lot about animal behavior, knew a lot about it. It doesn't take a long time to learn what mammoths and woolly rhinos do. But if your diet consists of a whole number of different species of antelopes and other animals, you need to know something about the strategy not only of those animals and their behavior, but also the strategy of the predators who live on them. So we came equipped with what we call significant depth planning. We had a really great planning depth. And when we moved into Europe, we were very tall, linear people with black skin, dark skin, because we're adapted to a tropical environment. We want tall, linear bodies. Why? Because we want to stay cool. We have a high body mass or a high surface area to body mass ratio. We have smaller body mass and lots of surface area so we can be comfortable in hot climates. Neanderthals were short and squat, remember? They're heat conservers. They're adapted to the world. People in the village where Tesfaye and I work, if we brought some of them here to the United States, they would die from the cold. They would die. If they went out on a cold Chicago winter day, they would die. Their physiology would kill them. Why did we survive? Because we were smart. And we had sophisticated technology, great planning depth, and we began to now hunt all the things like red deer that Neanderthals never ate. Plus, we ate rhino and mammoths. and we were impinging on their diet. And they had to move to other areas that they were unfamiliar with, and they did less well in. And the latest surviving Neanderthals we moved in at about 40,000 years to Western Europe. By 30,000 years, Neanderthals were gone. The latest surviving Neanderthals are found in the mountains of Spain, where they have obviously followed these herd animals. So we didn't directly kill them. It wasn't a holocaust. We came in and usurped their territory and their food, and we were much better. We were long-distance hunters. We could throw a spear several hundred yards and not endanger ourselves. We had division of labor. We had all sorts of things that allowed us to live. But physiologically, it's interesting, isn't it? We're adapted to tropical environments. And we know that we have light skin as an adaptation to European environments to let more sunlight in to synthesize vitamin D. If you don't synthesize vitamin D, you get rickets as a kid, and you die out. So it's a big question of where did they get their vitamin D from? Very quickly, I think, there was strong selection, because nobody's white and nobody's black, right? It's a continuum. And those individuals with slightly lighter skin left a few more offspring that survived, and there was selection for lighter skin. That's why we have lighter skin. We're all Africans, every one of us. Genetically, most of our genes are from Africa. Only the ones that mutated after we got out of Africa are European or Asian. So it's interesting that we outcompeted the animal that was most sophisticatedly adapted for that environment. The question I wanted to pose for Dave about this was that when we look at populations today who live in tropical or in Arctic environments, like the Inuit Eskimos, okay, the other thing about Neanderthals that's interesting is they have very thick bone. If you cut a section through a shin bone or a femur, the cortical bone on the outside is like that thick with a very small medullary cavity in the middle, which would mean that they had to have a heck of a lot of vitamin D to synthesize vitamin D to deposit calcium. If you look at Inuits today living in areas that are mostly cloudy, they have extraordinarily thin cortical bone because they're suffering from vitamin D deficiency. Where did Neanderthals get that amount of vitamin D from? Or did they have a totally different physiology? Which is an interesting idea. So we can talk about that later. So once we moved into Europe, Neanderthals slowly went extinct, and we ultimately emerged as the dominant species. And that's more or less where I want to leave the story. And if there are any questions about things, I'm happy to talk about them, or stuff that I've left out.
Don, we've talked a lot about the process of becoming human. Why don't you tell them what we're finding down at Mossel Bay that really throws the antiquity, what Curtis Marion's finding at Mossel Bay that's really pushing back the origins of culture.
I'll go back to my little walking diagram of getting more and more upright with the white European male. So where have archaeologists looked for the evidence, the earliest evidence of culture, and where it is that we became human? Europe, right? We've always found the most convincing evidence for modern human behavior, art, places that some of you have visited in the Dordogne, outside of Les Aisies. And only recently have archaeologists begun to really look in this later time range from about 250,000 years to about 70,000 years ago, which is called the Late Stone Age, Middle Late Stone Age in Africa. And at the institute that I direct at ASU, we have a scholar by the name of Curtis Marion. And Curtis is working right at the tip of Africa. If you go east to Cape Town, about an hour's flight to a place called Mossel Bay, there are a series of caves up in cliffs overlooking the ocean. Beautiful Indian Ocean. And they're very, very rich in archaeological remains. And he has a 10-year project there. He's just been given a $2.5 million grant from National Science Foundation, the largest grant ever given to an archaeologist. And what they're finding in these deposits between 70 and about 150, 170,000 years are ochre pencils that are obviously being used for decoration. They're finding ochre placards that have designs. They don't have naturalistic paintings like at Lascaux, but clearly someone is doing intentionally some sort of design. And they're finding very sophisticated bone awls and needles, artifacts that don't show up in Europe until about 30,000 years ago. And here they are in Africa at 70 to 150,000 years. 5 times as old as Europe. And what's interesting about, we have not found any human remains in these sites, but very sophisticated blade tools that you don't find in Europe till the Upper Paleolithic. And the geneticists who have studied the amount of genetic variation within a population find the highest level of variation that in diversity of alleles or genes in African populations, and particularly in Bushman populations. And many of the marker genes that they use to follow people's migrations around the old world are very old and ancient genes that are found in Bushman populations. So it looks like southern Africa may have actually been the crucible in which modern humans evolved. And we have a long-term project there. Ed and Janet are going to come for the very first time this fall. I'm leading a safari to South Africa, where we will see the first Australopithecus, the one found by Raymond Dart in 1924, which vindicated Darwin's idea. I often think when I'm lecturing in my classes, can you imagine Charles Darwin sitting in a biology 103 class? I mean, this is true genius. He didn't know what a gene was. He didn't know how things were inherited. Yet his idea of descent with modification, with natural selection, is still the grand unifying theory of biology. You know, the physicists and cosmologists are still trying to get the grand unifying theory of the universe. And here's a retiring old English gentleman who came up with the grand unifying theory of biology when he didn't even know about genes. But at any rate, I will be leading a trip down there, and Dart found a skull in 1924, which he called Australopithecus, southern ape, unfortunately, of Africa. And Australopithecus is the name that stuck because of a whole bunch of rules and naming things. And we'll visit the University of Witwatersrand, and we'll see the original skull, have an afternoon lecture by Philip Tobias, who's a legend. He's 80 years old now, and he gives a demonstration that is not to be missed. And then we go out to the actual cave sites in the Transvaal. We crawl down into one of these caves where there's a complete skeleton in a wall, human skeleton that's being excavated by a friend of mine, Ron Clark, who's at the university there. This guy fell through a shaft into a limestone subterranean cave, and his hands are clenched in this position. And his entire skull is there with the mandible intact. And Ron is slowly excavating this. Then we'll go out to the eastern Transvaal to just on the edge of Kruger, where we will stay 4 nights in a game park, and we'll talk about environment and ecology and adaptations and so on. And then we fly down to Mossel Bay and actually go to Curtis' site. And you guys will be able to see it for the first time. There will be major excavation. We'll have many of our students there. Then we fly up to north of Cape Town, where we spend 2 days looking at Bushman rock art in a gorgeous landscape called the Cedarburg Mountains, and then to Cape Town, and then the wine country of South Africa. Yeah.
Wasn't it near Mossel Bay that they found the fishing spears, or is that another site?
Stone Age and Neanderthals, they didn't eat fish. You need special harpoons and bone tools in terms of barbs for fishing. And there is very early evidence of fishing somewhere on the Southern Cape. I can't remember the name of the site.
Why Africa?
Well, I think Africa was the crucible for, all the major stages we think of human evolution. The separation from the apes, the acquisition of upright walking, the acquisition of stone tools, the development of large brains, and ultimately the development of modern culture, was because it presented a wide variety of opportunities for adaptations. And also, Africa was the place where, at the end of the Miocene, which is a 6 to 10 million year time period, when Europe was becoming temperate, and Asia was becoming temperate, and all the ape species were going extinct, except for the very few that evolved into things like orangutans and gibbons, and also Gigantopithecus in China, which was the largest primate ever to have lived. The lower jaws were that big. These were apes that probably weighed 800 to 900 pounds, obviously terrestrial. They're found in caves in southern China. So they evolved into apes in Asia. And in Africa, there was such a variety and diversity of environments and of species that natural selection had a much larger variety of animals to draw on to create these various species of pygmy chimps, common chimps, mountain gorillas, lowland gorillas, and us. So I think that played a very large role in the evolution of hominids or humans. And what's interesting is we think that, well, people became smart when they got to Europe because there were all these challenges. Well, without the technology, all the challenges do for you is keep you very narrowly constricted like Neanderthals. Whereas in an environment like Africa, where you had a vast number of opportunities to capitalize on, the more of a generalist you were, the stronger possibility was that your genes would survive. So I think what we think of as Europe as the finishing school is an idea that is now being totally overturned, and that Africa is really where we became intelligent, and brought that with us when we moved to the temperate climates. 1.6 million, which is called Homo ergaster. Ergaster is Latin for worker, and it was given to a skeleton called the Turkana boy that was found in the mid-1970s by Richard Leakey's team on the west side of Lake Turkana. And it's basically equivalent to what we call Homo erectus, like Peking or Java man. But what's interesting about the question that John asked is that's the first out of Africa. That's the first time. I think that primates, and humans in particular, are very curious animals. You want to know what's around that next bend right there. You want to know where the waterfall is. We're all just incredibly bright and inquisitive. Otherwise, Janet wouldn't have invited us. And ergaster gets out of Africa at 1.6 million years. Long before fire, which probably definitively is about 500,000 years old, where you're really producing it, controlling it, and using it. And we picked them up in Georgia, what was formerly the Republic of Georgia in the Soviet Union, just north of Iran, between the Caspian and Black Sea. And the route out was through the Middle East and up. And that's one of the reasons why I'm so interested in working in Iran, is because I think that if they got to the east of the Zagros Mountains, they had to have gone through Iran. And I was over there 5 years ago surveying up in the Zagros Mountains. And they're beautiful caves there. But there they are without technology. But as soon as tools are invented, they have such an edge over all other creatures that it really is the birth of culture. It's the thing that defines us. And that's the thing that drives human evolution so dramatically. So ergaster does get out into a place called Dmanisi, right on the Silk Route, interestingly. So hominids learned a long time ago the best way to migrate and trade goods and so on. So we find them at about 1.6 million, and they're almost identical to the skulls we see at Lake Turkana. Yep.
What is it about that Black Sea area that is such a fertile ground for adaptation and evolution? I mean, that's the area where the very first Indo-European word language was spoken, from which Sanskrit and all of our languages derive.
Well, as my colleague Gofar Bar Yosef at Harvard says, the Middle East is sort of like the bus station. Wherever you're going, you catch the bus. If you're going to Europe, you catch the bus there. If you're going to Africa, you catch the bus. Going to Asia, you catch the bus. And it is because the top end of the Red Sea, and probably the Bab el-Mandab, the bottom end of the Red Sea, is continuous at some time. It's the easiest way out of Africa. And the other sorts of things in terms of development of agriculture and so on, and I know almost everybody here has read Guns, Germs, and Steel, is that there were a lot of indigenous plants that were easily domesticated, that there were animals that were easily domesticated. Ethiopia is one of the few places that has an easily domesticated plant. Actually has two plants that you might know of. You know of one because you all probably had a cup of one this morning, coffee, which was a wild plant growing in Ethiopia in a province called Kaffa, and therefore we have coffee. And when it was first harvested, it was sent to Yemen, where it was roasted in a town called Mocha, and then sent off to Europe. Everybody thinks South America. I'm sorry to my South American friends, but Ethiopia is where it all began. And the other one was a wild grain called teff, T-E-F. It's pronounced teff. And they use it to make these flat pancakes. So but the rest of Africa just didn't have domesticatable, if you can say that. They didn't have plants and animals that could be domesticated. You can't domesticate a zebra and use it as a draft animal or a riding animal. But in the Middle East, you had a whole series of grains that were wild that could be domesticated, selected for, and grown. So, and Guns, Germs, and Steel is the best place to read about that. Yes, Megan?
Kind of general question. Does evolution stop?
Oh, well, that's going to be Dave's lecture. Does evolution stop? I'll give you a very simple answer to that. Every time you breed with somebody and produce an offspring, you've introduced a new combination of genes that has never existed before. It shows you how powerful biology is, how powerful DNA is. There's probably the combinations to make, no two of us are the same here. And there's never before, unfortunately, been a Megan. Right? You're so unique. I often say to my students, and I'll say to all of us around here are the lucky ones, we're going to die. Because the probability for you to be you or you to be you is so it's so huge. I mean, the improbability of being you, that there are more combinations than there are stars in the universe. Okay, so the fact that you got born is unbelievable. One little change and it'd be somebody else. My students always, what do you mean? We're the lucky ones, we're going to die. Well, you're going to die because you were born. And the probability of you being born is infinitesimally small. One little change and you'd be somebody else. So each time we have a mating union and an offspring, there is a change. Evolution has changed. Now, Dave will talk more about this. We talked about diseases and medicines and disease and so on. But we all belong to a single species. Someone said, well, gee, you just said as recently as 50,000 years ago there were 4 species of humans living on the planet. How could that be? Well, they didn't have United Airlines or Lufthansa to get onto a plane and fly to Australia and mate with Australians. If you were in Europe, isolated by glaciers, and natural selection was moving you in a whole different direction, Africans never got in there. Asians never got in there. So you had widely separated populations that were independently evolving. You keep a species a single species when there's inbreeding, interbreeding. And today, all humans breed with each other. So in a way, if we take it to its logical conclusion, with enough of this, we will become more and more similar to one another and less different. There will be a homogenization, not only of cultures, but of biology, which will be bad because we'll reduce the variety or variation in gene pools. But the one instance, so people say, will there be a new species of human? I call ourselves Homo egocentricus rather than Homo sapiens because we spend all of our lives thinking about ourselves and nobody else. I hope we become Homo introspectiveness because we need to make right choices about the future if any life is going to survive on this planet. But I could see a scenario where we sent a spacecraft off with a whole vat of frozen embryos, right? We had fertilized them in utero. And 5 million years from now, out in space, the computers went, turned it on, and this began to melt. And they began to divide. I think it's the only way we're going to do long space travel. And then 5 million years from now, people are born and raised by videos and computers and so on out there in space. And it takes them another 5 million years to come back to the planet. Who knows if humans will even be here. But with 5 million years of separate evolution, we probably would be a different species because of recombination and so on. But Dave's the guy to ask about this stuff. Anything? Whenever I go to work in East Africa and Ethiopia, reporters always ask me, what are you going to find? And I always say the unexpected. Because whenever we go and look, we seem to find something different and intriguing, and as we say, opens up a whole bunch of new questions. And you can make some good guesses, right? You're going to find Australopithecus, or you're going to find early Homo with stone tools, or you're going to find this or that. You can make some predictions. But the one prediction that no one in the entire field would have ever made was a discovery made 3 years ago on the island of Flores in Indonesia. In Indonesia, there is an island, and islands are wonderful places to study evolution. If you ever read any of E.O. Wilson's work on island biogeography, or the Song of the Dodo, which is a wonderful book on island biogeography, because they're sort of enclaves, right, where evolution's going on separate from everything else. And what's one of the most marvelous set of islands to study that, of course, was the Galapagos. But on this island, archaeologists found in a cave the remains of 3-foot-tall people that had brains the size of Lucy's, about 400 cubic centimeters, 1/4 the size of an average person today. Okay, and they were making not sophisticated tools. They didn't have, Swiss Army knives and things, but they made pretty sophisticated stone tools, and they were hunting lots of dwarf elephants, dwarf mammoths on this island. And this is only 18,000 years ago. They had gotten isolated there, like Neanderthals had gotten isolated in Europe, and they underwent, I think, I've seen only a cast of this skull, which I held in my hand at the American Museum of Natural History. And it looks like you've just taken a modern human skull, put it into Adobe Photoshop, and made it smaller. It doesn't look like some sort of strange pathological dwarf with beaking and twisted teeth and strange-shaped cranial case and so on. It looks like our skull made small. And if you look at island biogeography, you see that there is a tendency for dwarfism in islands. Natural selection selects for smaller-sized mammals because there is on a smaller island, like Flores, I don't know the size of it, but it's small, there's reduced availability of natural resources. And those animals that don't eat as much have a higher probability of living and reproducing and passing their genes on. So the smaller individuals were selected for. But what we don't understand is why the brain is so small. Because throughout evolution you see brain increase going like that. And there's a selection for intelligence. It suggests to us now, and we've always kind of felt this was the case, but this is the personification of this view, that it is that again, Ed, size isn't everything. Because it's the wiring in the brain. When you look at Cro-Magnon or pre-Cro-Magnon man, and even Neanderthals, they had big brains. Neanderthals had brains up to 1,800 cubic centimeters. 400 centimeters bigger, a whole Lucy-sized brain bigger than our brains. Yet they were dumb, relatively speaking. So it really seems to be the wiring. It seems that, the hardware is important, but there's something about the software that goes in there.
They were human laptops.
Yeah. You notice how our laptops are getting smaller, but more powerful? So, and it probably has something to do with information processing, which is somehow related to the numbers of connections between neurons and the numbers of multiple tasks that one can do, and so on. So these are enigmatic. There will be a book coming out next year by the discoverers about floras. It's been a stormy discovery because someone has stolen them and taken them to his lab in Jakarta and damaged them, and now they're back to the original owners. It's very complicated. And I do write an essay about it in my upcoming book. I have a book which you all have to have on your coffee table, so I can afford to come back to the Grand Canyon someday, which is called From Lucy to Language. And it is that span of the human career. It's being published by Simon & Schuster this fall. It's a large format book with, for the very first time, life-size photographs of all the important discoveries. And I've written an essay to go with every one of the important discoveries, telling you why it's important. That's the second half of the book. It tells you where it was found, when it was found, who found it, its age, and first publication. And the first part of the book is many of the questions that we've asked this morning. I've written short essays about, what is the oldest evidence of fire? Why is paleoanthropology so contentious? How do we